I'm a second year, mechanical engineering student, and it's finals week, and I have not started studying yet. I'm actually like really scared. I have two finals that I'm worried about, and one that I'm not really worried about. Um, and the one I'm worried about the most is physics E&M, which I know like everyone I talk to says that class is easy, but like I don't think it's easy. I'm like suffering. And then the other one is statics, which it's like it was much harder at first, but like it got easy as we went on. But like I still like want to make sure I feel confident on like the older units and stuff. So yeah, I think I'm gonna start with that. I'm gonna do a bunch of like the old exams, cause we had 4 exams, and then the finals like cumulative. So I'm gonna do like practice exams 1 through 4, and we'll see if I get them right. I'm gonna do, cause he hasn't posted for every year since 2018. So I'm gonna do 2023 first, cause my friend said she did 2023, and then we can like cross reference each other. I guess if I got like, cause he posts the final answer, but he doesn't post like the solution. So like it's kind of annoying, but I understand why he said it, so people don't just like copy basically. Like he wants you to actually like, work on the problem and then like figure out what you did wrong afterward. But it's like whatever. That's a whole other like other I don't know what I'm looking for the word. But yeah, okay. So I'm gonna start with test 1, and I was trying to decide if I wanted this to be like a time lapse or like actual like time, but I might just do it like regular, just because then it can be like a study with me, you know. Okay. And then I don't have to like do any editing, so it's like yeah, okay, whatever. And I recently, bro, I finally fell for the Good Notes propaganda. It's actually like kind of worth it, because I was using Microsoft OneNote for the longest because it was free, and I could also like access it on my computer, like my notes. And then I tried GoodNote, like I was doing like just a free trial, and I was like, oh my gosh, this is so good, because it has like so many more features than like the one I've been like OneNote. And then I bought like I did like the subscription based model, so then I can have it. What am I saying? Oh, I can access the stuff on my computer as well, and it's like $12 a year. No, it was $10 a year, which like it's not that bad considering like like I drink coffee, you know, and I pay for my coffee with my like school meals, and I work at the cafe, so like I get it for free. But it's like when I think about like I would have been spending that money on coffee, you know what I mean? And it's like it's kind of worth it, you know. That's like the mental gymnastics I did to like justify my purchase, but whatever. Okay, I'm gonna shut up and actually start working on it. Oh, I should probably like put the problem on the screen so I don't have to keep looking up. I mean, no, I guess I could. I'll put it on the screen like some side, this side, that side, maybe. Who knows? Okay. I need music. Oh, and also I'm NRA, so I'm on duty tonight. So I was trying to think what time I should stop studying so that I can, because once I'm on duty, I can't leave like my assigned like areas, because I do 2 buildings. So I'm like, I don't know, I might, because it's currently 5:46, so I might go, and my duty starts at 8. I might leave at 7, go pick up something to eat, because I'm probably gonna get hungry around like 10 p.m. and then, but I also don't know, I feel lazy and it's cold cold outside because it snowed the other day, and I'm like, I don't think I want to do like that walk in this cold. But I do like the cold, but I just like my butt's gonna like freeze off. But whatever, we'll decide. Um, my professor keeps like, well, not yelling, but he's always upset with me because I always forget to like write my units. So I need to like make that a conscious habit. I think that's the only one I missed. Yeah. Do I need it for the meters? Oh, probably, right? It's fine. Oh wait, you can't even see my iPad this whole time. Hold on. Is that better? Wait, back or? I don't know, man. Okay, that's good. Mm-hmm. Okay, I kind of have a dumb question. Well, I mean, I'm asking, but like, it's not like me asking out loud. But okay, I'm looking at the force, right? Oh, hold on. Because it asked for the resultant force acting at point A, so I don't think F3 will be included since it's acting at point D. But then I'm like, would they have that in there just for like show? You know what I mean? I don't know. Like, Okay, looking at the answer key, like I said, he doesn't include like the actual answers. I mean, the actual solution, just the answer. And okay, I'm not supposed to cheat, but like it's not cheating, it's practice, whatever. I think he does include the force acting at D as acting at A. I mean, I guess because if you're yeah, I mean it makes sense, right? Yeah, I'll just include it. don't know why my Apple Pencil keeps like glitching out. It's like being stupidly slow. Like, do you see that? Like, I mean, I don't know. It's like, it's pissing me off. Dude, what is going on? Wait, okay, 90, 90, 0. Okay, I got problem 1 right. Okay. Now for problem 2. I think, I'm gonna close Goodreads and reopen it. Wait, let me make sure this is saved. I don't even know. Okay, whatever. I'm gonna close it, reopen, see if that fixes the glitching. Okay, now on second problem. I'll put it up here, somewhere. If I decide to put it up, actually. I actually don't know if I'm allowed to share these. I don't know. We'll find out. Okay, so wait, okay. I'm thinking. Oh, no, I need to pause music for this one to actually think. Okay, I was thinking because beta is 60 degrees and f of x, sorry, f of y, over f is cosine of beta, but we don't know. Oh my god, wait, no, this is why no, it's because cosine beta is not unknown. See, because I was treating beta like unknown, I think that fucked me up. Okay, so we know cosine of beta, which is 60. Cosine of 60 is 0.5, so we know 0.5 is the same as fy over f. So if we write, should we do it in terms of y, in terms of fy, in terms of f? Let me see. What am I thinking? I'm just gonna do it. Let's try it this way. And if this one, we'll change it. So 0.5 f is equal to fy. Okay, let's see if I'm cooking. So then f is equal to square root of fx, which is 300 plus, 300 square, which is gonna be 90,000, maybe? Yeah. And then plus 0.5 f square. I'm just gonna write it as 0.5 f square. Wouldn't it just be 0.25? Hold on. 0.25 f square? Just for continuity's sake. And then plus fz squared is 600, so 360,000. Yes? No? Maybe so? Let's see. Yeah. Okay. So then we can square both sides. To get rid of the square root, we'll have f squared is equal to 90,000 plus 0.25 f squared plus 360,000. And then we combine that, we have f squared equal to 450,000 plus 0.25 f squared. And then if we get it on one side, I think we can do an equality. Not an equality, what is it? Solve for x, right? Like if it's do I suppose I need to do that if we had 0.75, subtract it off, 75 f squared equal to 450,000 and then divide by, so f squared is equal to equal to 600,000. And then we take the square root of that. So f is equal to 774.60. Let's round it to 60. And then fy would be we do the inverse, whatever. So cosine of beta is equal to fy over f. So f times cosine beta equals fy. So cosine of beta was half, I'm pretty sure. Yeah, cosine of 60 is half. Alright. And then times, so what am I doing? Hold on. So fy is equal to 387.30 newtons. And then for number 2, if I'm right, and I'm just gonna try to do it all in one shot. So cosine alpha is equal to fx over f, and we're looking for alpha this time. So alpha is cosine inverse of 300 over 774.60. Six, 7. Sorry, that's like literally whatever. Okay, and then gamma is cosine inverse of 600 over 774.6. degrees. Okay, let's see if I got it right. Oh wait. Ooh. Okay, I got everything right except for the alpha. Oh, that was my number. So hold on. No wait, not alpha, except for, wait, no, it was alpha. Except for alpha. Why was alpha wrong? You know what it might be? Maybe I think I might have done it from the, I didn't do it from the positive. x-axis. Yeah, when I subtract by 180, it's correct. But I'm confused because, like, the formula we were given. I mean, I guess when you're looking at the graph, it is. Okay, I do see why. Okay, I get it. I think I get it, at least. Whatever. I still count it as a win because I think my professor would have understood where I was coming from. Okay, so okay, whatever. Regardless, as test 1 completed, and now we're gonna start on test 2. So this first one was just like basic, like, I don't know, stuff, like vectors and stuff. And then test 2, I think, was when we got into doing, whatever it was. I think something. Oh, let's see how long it took me to complete this. Okay, 37 minutes. Okay, that's not too bad considering, like, when we had the actual exam in class. It wasn't this one. This is the 2023 version, and it's 2024 right now. 2025 right now. And when we had in class, it was a 1 hour 10-minute exam, a 1 hour 15-minute exam. No, 60-minute exam. And I like finished right on time. So that took me 60 minutes versus now it's 37. So like, I think there's some improvement. You know, could always be more, but we're not doing too bad. I love like this ColourPop cover girl lip glosses. There's a hair, but I love these. This is my favorite flavor or scent. I don't like them, but I do enjoy this one. I'm pretty sure it's, I actually don't remember. I Saw You Later? No, it's not. Hold on. Maybe it is. I just said it's my favorite and I forgot it, but it's because like I just when I want another one, I usually just like repurchase it on Amazon. But except actually this one, I got it from Secret Santa from my club last year for Christmas, and I just haven't finished it yet. Okay, what next? Oh, test 2. Sorry, I'm getting distracted. This again, just the 2023 version, not our version, but like, just looking at it, I'm remembering that I hated the concepts that I covered. Oh, I just doxed myself. I'll probably have to clip that. Cause no one. I didn't mean to say I meant copy. Fuck. Okay, so it first asks for. Oh, I need to pause the music. Okay, at first it asks for force vector f1, so I think it's just asking for a Cartesian vector notation. And it's directed along BG, so we just need multiply the 50 Newton force by our BG, no, by the unit vector BG. Okay, so first I need to write out. Sorry, I'm just looking like, bro, just mute me. Like, I yap too much. I just talk too much. But like, it helps me think, you know. And then zero energy is okay. Awesome. And then from here, okay, let's check if I did the first one correctly. Because I just realized I didn't want to sit here and work through the whole problem. Just to later realize I did it wrong. That actually pissed me off. Because I won't even know like where I went wrong. You know what I'm saying? Okay, wait. Exact numbers. Okay. Okay, I'm cooking. Alright, but alright, so then B, 1B, it wants the angle between F1 and the cable BH. Okay. I think for that one I could do like the dot product. So BG, the dot product goes cosine. No, it's fuck, do I remember it? A dot B is equal to cosine of vectors A times B over the magnitude of A times B. Some shit like that, right? I believe. Let me just pull up the course notes on dot vectors, on dot product, just to make sure, because again, I don't want to spend my time and I don't know like where I even went wrong. I feel like it's valid to look up formula after I try in my head, because for like our exam we're not allowed like a cheat sheet or anything. Actually, should I not do it with no resources first? And then like if I need the dot product, I mean if I, oh fuck, I bit myself. Also, I think I added an extra step in there. Yeah. So it's, yeah, I'm stupid. Dot product is cosine of theta is equal to a dot b over ab. I think in this case ab are vectors. He doesn't really like, it just says, I mean, I guess because you're supposed to know and I'm just dumb as fuck, or I'm just quite stupid. I shouldn't use such foul language regarding myself. Okay, yes, so I think he's the, I mean, the bottom is not the denominator is magnitude, like like I thought, and then the numerator is the vectors. Okay, so I'm gonna write it in this notation. Okay, so since we are looking for theta, oh wait, that means I was almost, girl, shut up. Whatever. So, oh, my iPad's almost dead. So theta is gonna be cosine inverse of vector a dot b over the magnitude of a and b. Okay. Let me grab the charger. Okay. Oh, I forgot to hit play on my music. Okay. Okay, I got the angle wrong, but he doesn't post a solution, so I actually don't know what I did wrong this time. Okay, let's do some thinking. So it's off. That's just off. It's off by a couple degrees, but I don't want to be like, oh, it's off by this much degrees, because like that don't really help. Okay. I feel like we're supposed to use the dot product for this one, which I think is what I did. So if I messed something up, it was with the dot product. Or I know that. Okay, so what do we know? We know since 1A was right, that means my vector RBG was right. So maybe when because I didn't recalculate like all those values, so I might have chosen the wrong thing in the calculator. Okay, so that's the magnitude, which is what I used there. Okay, I don't know. I doubt this matters, but RBG, the one we did earlier. H was 0x 0.875y 0.75z. Okay, that much is right. And then the vector RBH is h minus b. So h being 0 minus b negative 0.75. 0.875 minus 0.5, 0.375. 0.75 minus 0, 0.75. The magnitude is and then do the square root 1.125. I got it! Oh my gosh, yay! Okay, so basically, what happened was when I was redoing the magnitude, I forgot to take the square root. Okay, whew. I'm probably gonna end up speeding that part up if I remember, because me just sitting punching numbers into my calculator probably is not entertaining. Oh my gosh, wait, that actually makes me so happy. Okay. Okay, yay. Wait, yay. Okay. Next is say. Okay, I know I'm sorry I keep doing this thing. It's just there's something about my. Okay, Percy asked for a scalar projection of f1 onto HB, and I think to do scalar projection, you'd multiply it by the univector. So we're gonna find a univector of HB, which we already have. Well, I did it. Oh wait, they thought they could get me, because what we have right now is BH, but they want it to HB. So you're supposed to actually like think and shit. Okay, so wouldn't it not just be like opposite of everything? So B minus, so it would just be the same numbers, but like whatever ones are positive would now be negative. No? Yes, it would be. Okay, so R, but then the magnitude would still be the same. So we would just have, okay, I think I get it. So RHB, which is what we're doing this time. Okay, I'm gonna put music back on so I can shut the fuck up. I got it right. I got it right. Okay, wait, this one's kind of confusing. If a second force, hold on, I need to pause to think. If a second force F2 of magnitude F2 equals 70 newtons and parallel to the YZ plane is applied at B, calculate the direction angles that it should have to make a scalar projection onto HB0. What are we talking about? Okay. All I know is that for the scalar projection to be 0, what does that mean? It means they would have to be perpendicular. No? Yes. Wait. Would they be? No, they would be parallel? Wait a minute. No, because it just said parallel to the YZ plane, so I think it has to be perpendicular, right? I don't know. I don't know how to do the word actually, now that I think about it. If a second force F2 of magnitude F2 equals 70 and parallel to the YZ plane is applied to B. So is it saying this for the scalar projection of F2? Oh fuck, that was my name. The scalar projection of F2 should be equal to 0? Or that the scalar projection of the resultant force should have to be 0? I feel like I think it would be of just F2, right? Okay, so if we want the scalar projection of F2 equal to 0, oh, we know we don't have alpha. Wait, no, we don't. Because if it's parallel to the YZ plane, oh, we should know. That should give us an angle. Which angle does that give us? I think that gives us that, wait. It's parallel to the YZ plane. Okay, so you have your XY. You have your XYZ. It's a Z, so it's Y, X. So it's somewhere here. Anywhere here. Oh, then it's 90 between it and X. So we have one of the angles. We know alpha is equal to 90 degrees, which, I mean, does that tell us much? Sine cosine of 90 is, what is that, 1? Oh, it doesn't exist? Oh wait, I did cosine at first. Cosine of 90 is 0. Right, that makes sense because it's entirely in the Y and Z plane. Duh. Okay, so that makes sense. And then, so we need beta and gamma. I think we're supposed to use the fact that cosine square of beta plus cosine square of gamma plus cosine square of alpha is equal to 1, which is then equal to unit vector, some shit like that, right? No. The unit vector is, hold on, it's okay, whatever. Oh, let's just do something. Okay, so we know that A times UA is equal to AX plus is equal to AX, AY, AZ, whatever, right? And A times the cosine of beta, right? Because we just went over cosine of beta equals AY over A. So A times cosine of beta is same thing as AUA. Yeah, so the cosine of the stuff is the same thing as the unit vector. Okay, so then what? Okay, so where's the questions? Where's the tab? Okay, here it is. So so 1 is going to be equal to cosine square beta plus cosine square alpha. What does that tell us? Absolutely nothing. Okay, I paused because it was taking me too long to think, but I suddenly okay, what if because since it was saying you wanted the scalar projection to be 0, right? When you're doing this scalar projection, you use like the component of the component of the vector. So we know f2, well, we don't know f2, but we know it's 70, and since we know there's gonna be no x component, so the y component is 70 times cosine of beta, and then so that's the j hat component, and then that is 70 cosine of gamma as the k hat component, and then we want that the scalar projection be 0. Sorry, I need to stop fucking with that. So basically now 70 cosine beta, we want the dot product to be 0, so that dotted with UHP, which is 0.33, so times negative 0.33, oh, I put the negative before the dot, hold on, times negative 0.333, right, that's 1, and plus 70 cosine gamma times I think it was negative 0.67 negative 0.667 k, and we want the whole thing to be equal to 0, and we don't include the x component because it's going to be 0. So then you have well, let me put it on this side so I can actually see it. Okay, so 70 times 0.33, 23.31, so 0, 23.31 cosine of beta plus now we have two unknowns. So, oh wait, it's the zeros already on that side. So, look, what I do from here. Subtract 1 over. Okay, maybe I wasn't cooking. 49.67. Negative cosine gamma is equal to cosine beta, and we're gonna divide that by 23.31. Oh wait, where did I get 49.67? It was 46.9. I'm blind as fuck. 46.9. Divide that by 23.3. It's about 2. So negative 2.01 cosine gamma is equal to cosine beta. Okay, that's all we have so far. Okay, looking from there, I don't really know what to do. Okay, I'll be back when I think of more. Okay, wait, remember earlier when I was saying how, like, let me copy this, move it to the next page, but when I was saying how a 1 would be, how did I copy? Wait, here? Okay, 1 would be, one would be cosine, beta square plus cosine gamma square. So now we have cosine gamma in terms of cosine beta. So then can't we just say 1 is gonna be equal to cosine, wait, what am I saying? Alright, cosine square gamma plus negative 2.01 cosine gamma square. And now we have the same term. Let me cook. So then from here, negative 2.01 squared, and we have 1 is equal to cosine square gamma plus 4.05 cosine gamma square, or cosine square gamma, and then we add a 1, so 1 is equal to, wait, that doesn't seem right though, I'm kind of scared. 5.05 cosine square gamma. Can you add that? I actually don't know. Whatever. 1 divided by 5.05 is equal to cosine square gamma. So now 1 divided by 5.05 is 0.198 is equal to cosine square gamma, right? So now you take the square root of both sides. It's going to be equal to 0.445 is equal to cosine of gamma, and you do cosine inverse, and I don't need to write it all out, let's just write gamma. It's going to be equal to, I got 64 degrees, and then now we come back up here, excuse me, sorry. Cosine of beta is negative 2.1 times cosine whatever, so then cosine beta is going to be equal to negative 2.01 times 0.44 whatever, so negative 0.894 is equal to cosine beta, and then you do the inverse of that, and you get beta is equal to 153.44 degrees. Okay, let's see if I was right. Wait. Guys, oh my gosh. Wait, I'm not cooked. Okay, I rounded it too much from here, but like based off my calculator, I was right. Okay. Wait, I'm still ready. How long did that one take? I feel like that did take longer. Well, I was gonna base it off of subtracting like from my recording time again, but because I paused to think it doesn't really count. I'm not gonna have time on the exam to really like pause and be like, how would I do this? So I just need to, but I think like, the practice is definitely helpful because I'm going through it now to like think of how I would do it on the exam. You know what I mean? So like I think this is being helpful. This is pretty helpful. Okay, I think there's two problems for this one. So yeah, and it's one of the ones I hate. It's like the maximizing the like um uh the mass that can be held by a jaunt or whatever. I hate those problems. I always forget how you're supposed to like go about them. So let's see. I've low-key been studying for a while now because remember I started, it was like 5:46. I've been here this whole time like actually studying. It's currently 7:12. So even though I haven't made much progress, I've actually been here for a while. It's been like an hour 30, almost an hour like 26. So okay, not to lie, that's like kind of short. Like most people study for longer, but like I'm not a good student, so like I low-key don't really. So I'm thinking I might pause, go grab dinner, like I said, because I do have to be on duty in about 47 minutes. So I might pause, go grab something, so when I get hungry later, I have something to eat, and then come back and continue studying. But then when I come back, my door has to be open, and like I'm gonna feel awkward like talking to a camera. So like I don't know what we're gonna do, but should I start? Try to start this problem. I mean, why not? Let's just at least like develop a means of attack. Oh, I meant to call. I keep doing that stupid stuff. Whatever. Okay, so 2 is asking for the large, if the department mass largest point in the structure can obtain. Okay, actually this one might take me a while, so I'm gonna go get my dinner and then I'll be back. Okay, so I'm back from grabbing my dinner. Oh my god. Well, sorry. I'm back from grabbing my dinner, and duty's about to start in 3 minutes, so I'm like, this is the last time I'm gonna talk to the camera before midnight, because I think I'm done. I can close my room door after 12:30. So before that time is probably the last time I'm gonna talk to you. Why the fuck does my face look like this? Hold on. I fucked my hair up probably when I fucking sorry. I messed my hair up probably when I was out there. So anyways, here's what I got for dinner. They actually like, it was kind of fun today. They had potato wedges and rotisserie chicken, and then I just poured some teriyaki sauce on the rotisserie chicken. Where's the camera? Oh, right here. Put some rotisserie sauce on, not teriyaki sauce on chicken. So I have teriyaki chicken and potato wedges for my dinner. Okay, they didn't have utensils, so the only thing I have is a fork. So they're pretty good. It's pretty good. Tastes like teriyaki. Yep.